Welcome. Welcome to Wharton Moneyball. Welcome to a full hour of sports analytics here on the Wharton Podcast Network. This is Cade Massey hosting this week at the moment with my longtime friend and collaborator, Eric Bradlow. Shane Jensen is out this week, sadly, tragically, but Adi Wyner will join us just a little bit late. Adi is in transit at the moment. Some combination, as you guys know, some combination of us are here almost every week of the year and have been for more than 12 years now, talking sports analytics with you guys. We are going to run our usual format this week. We're going to run a guest in the first half hour, and then we'll do open lines. In the second half hour, me, Adi, and Eric will kick around a few things. I am piped in from Austin, Texas. Eric is from Huntsman Hall, West Philly, on campus. Mark, I'm assuming is New York. I don't know that for a fact. Mark Broadie is our guest in the first half of the show. He is a longtime friend of the show, and we're always delighted to get time with you. Mark, thanks for making time for us.
Thanks for having me. And yes, I'm in New York, and looking out over the Hudson River, which you can't see in my background because it's the way I'm looking, not behind me.
Right. Mark, as some of you guys know, is at Columbia, the Columbia Business School there in New York. He is the Carson Family Professor of Business there. He came out of the quant finance world, but he is best known in the sports analytics world for his contributions to golf. He flat out invented the concept of strokes gained, which is just kind of ridiculous. It's one of the great sports analytics stories of our lifetime, and continues to be engaged in the sport at multiple levels. He has a great book, Every Shot Counts. We'd strongly recommend his book, Every Shot Counts. He consults to professional golfers, and he has been involved with revising the ranking systems of various associations, including the World Golf Ranking System, which is like the biggie, but also NCAA ranking system. So something we want to talk about at some point with Mark is that's a fun topic for us. But maybe we'll start, Mark, with just, this is kind of in some ways peak golf season. We're a few weeks post Masters. We're a week before the PGA, which is going to be in the Philly area. The majors are all lined up now, one a month, which is fun these days. What is on your mind? What is on your docket right now in the world of golf?
Well, I would say that I don't really follow golf as closely as some fans do, certainly not as closely as Rufus Peabody does. Mm-hmm. But I look at more kind of longer term problems, and actually my day-to-day stuff recently has been with college golf rankings and professional disc golf rankings. And this is the ranking season for college golf because
right.
Like the March Madness basketball tournament, the main use of college rankings, besides bragging rights throughout the year, is determining which teams go to regionals. And that's run by the NCAA. And then from regionals, you go to the nationals, and then you crown the national champion.
Yeah.
So it wasn't clear to me how this ecosystem worked until getting into the rankings. But the colleges, universities themselves choose their schedule, and teams run their events. And it's kind of in coordination with the NCAA, but the NCAA isn't running all of these events.
Right.
So we're keeping track of all that's going on and then ranking the teams throughout the year. And then at this point in the year, then the qualifiers for regionals are set. So there's some interesting problems there in the rankings. There's some interesting problems also, which is more operations research, I guess, than sports analytics, which is how do you assign the teams that you have selected into the 6 regions?
Okay.
So that comes up in many sports, but I was involved in it this year in golf.
This sounds like a ball, frankly. Let me say, interesting that you mentioned Rufus at the top there. I happen to know that Rufus and Mark occasionally play golf in the New York area, so these guys are friends. But yeah, Rufus, not a trivial part of his living is made watching golf, paying attention to golf very closely. But one of the first things we ever did together, when he was shortly after he was at Yale, the Yale women's golf coach at the time asked us if we could help develop a ranking system for women's golf because they felt they were disadvantaged being in the Northeast, playing different tournaments, playing a different time of year. They thought whoever the cabal was in Oklahoma that ran the college golf rankings. Maybe they're still the cabal. Maybe you're in with the cabal now, Mark. I don't know. But that coach was not happy with it, and we dabbled a little bit. It was good fun, but I could imagine that's great fun to get into.
It is absolutely great fun, and I would argue that the previous rankings did appear to be biased in certain ways, that if you played a stronger schedule, that you would be ranked higher for an equal level of performance, but that requires some analytics in order to prove that.
Right.
So I've heard a lot from coaches, but then when I developed this new ranking system, which has been in place this is the third year, I then hear questions from coaches, and I realize that just because people are criticizing the ranking system doesn't mean they're right. You really need to go into the analysis to figure out, back then was it biased against teams in the Northeast or not? Just because and that's another thing that's almost as important as the analytics, is being able to convey the underlying rationale and to communicate why it's fair and to convince people that it is fair. Because I don't know how many times coaches have come up with the question to me, we have beaten this other team twice in the season. By that means they played in the same event and they finished higher in the final leaderboard. We've beaten them twice, therefore we should be ranked higher than them, but we're not. Your system is messed up.
Yeah. Sure.
And so it's like, well, how do you answer that question? And the most direct way I could find to answer that question was to show cycles. So I found in the data, just looking at wins and losses, Team A has beat Team B 2 or 3 times. Team B has beat Team C 2 or 3 times.
Yeah.
And if you argue that A has to be ranked better than B and B should be ranked better than C, then A should be ranked better than C. But that's C beat A 2 or 3 times total. And then you realize you can't use that logic. It's completely impossible to have a ranking system that would satisfy that criterion.
Right. So I think it's the NFL that by some point in the season every year, the circle's complete, that everybody has beat somebody, and transitive property takes us all the way around. Eric has a question. I just want to say real quickly, Eric, you don't know, like you probably don't quite understand that he's hinting at the greatest playoff tournament format in sports, the one I get fired up about every May and June, the college golf tournament. Mark, I don't know if you've heard me rant. Every year I make the guys pay attention because they play this, 3 or 4 or 5 rounds of stroke play to identify the 16 or whatever it is teams that play match. And it's just freaking brilliant, in my opinion. But let's leave it there for now. Eric wants to jump in with a question.
No, I just had a clarification question, Mark. Are the rankings, like literally it's a deterministic function on who qualifies based on the rankings, or it's used like in college football, like it's an input to some subjective committee? It's a clarification question. I'm just asking which one is it?
It's more the latter. It's an input, not a rule. But in practice, more of the divisions follow the ranking exactly than don't. But where it comes up is usually in borderline cases, when you draw the line and you take a look at the teams right around that line, and somebody will make an argument, and I think it could be a valid argument, that the rankings aren't perfect, and there might be some reason to take the team that's ranked 1 out rather than 1 in, across the line. But also when you do that, then the committee that makes the ultimate decision needs to justify it, because it's the team that got kicked out that was inside the bubble is like, oh, well, you better have a good reason for not letting us get in.
Should I assume, Mark, that the distribution of team, let's call them strengths or rankings, is what we classically see, that there's greater separation out in the right tail, but that right near the cut score, there tends to be bunching, and therefore there's a significant number of teams that could argue, I should be above the cut line or not. I assume that follows for rankings as well.
I think it happens in just about every stat that I've looked at, including rankings. So you're exactly right there.
Mark, let's talk about, first, one more thing on the college thing. You said it's interesting how they assign them to regions.
Yes.
So, and you said this is kind of an OR question, but what are the considerations? So you said there's six regions. What are the considerations?
Yeah. So once you decide on the 72 teams, and it's not in rank order because the conference champions get in.
Mm-hmm.
So Columbia women got in this year because they won the Ivy League championship.
Mm-hmm.
And so conference champions get a free pass into the regionals. And when they're not ranked in the top 72, that means there's teams that are ranked higher that get in place of other teams. But once you have the 72 teams, the 6 regional hosts, the 6 locations have been determined years in advance. So now the question is, how do you put those 72 teams and assign them to 6 regions?
Mm-hmm.
And the multiple.
Why don't we listen? Since we're all math people here, is there an objective function, literally a mathematical objective function that's maximized by that assignment? Except if it's an OR problem, there has to be an objective function, right?
Well, the problem is there's 3 or 4 objectives.
Good.
And the question is, how do you weight them? But by far the number one objective is to make sure that the top 6 seeds, the top 6 ranked teams, which would be the number 1 seeds in each region, have the easiest and an equal shot of getting through. In other words, you want to make sure there's regional balance. You don't want to put a bunch of strong teams in one region and a bunch of weak teams in another.
Mm-hmm.
So the number 1 criteria is so that the number 1 seeds have the best chance and a nearly equal chance of getting through, and the same with the 2 seeds and 3, 4, 5 seeds.
Mm-hmm.
And even so, that's one objective, sort of this regional balance in terms of strength of each region. The other that I found out that they care about is they don't want one region to be overloaded with a bunch of teams from one conference.
Mm.
So it seems like it's a repeat of a conference championship and they have to duke it out somehow.
Mm-hmm.
Somebody's going to get left out just because they happen to be in the same region as same
Mark,
conference.
let me ask you a question. If I gave you the 72 teams, suppose we all agree I'm not saying we're agreeing on what those teams are, but I give you the list of 72 teams. Could you write down the criterion, like you just mentioned, the top team should have the easiest path. We don't want too many teams in the same. Would some algorithm now just pump out those 72 broken into the 6, or would there still be subjectivity there?
So yes, actually to both, because the last one is travel. So I put that in as an objective, but it's less important than I had thought it would be. Mm-hmm. But I put it into an optimization problem and it will spit out an assignment. Mm-hmm. And then they will look at that assignment in more detail and find reasons for doing swaps. Mm-hmm. Mm-hmm. And because there are many, many assignments of these 72 to 6 regions that are nearly comparable, this to me is a way of choosing among many good alternatives. But the algorithmic viewpoint gets you to a really good starting place, which is very hard to do manually, which is what they were doing before. Mm-hmm. So what the standard practice is called the S curve.
Yep.
Which is teams 1 through 6 go into these regions, and 7 goes where the 6, and then you keep on
going it around.
Right. So we made the algorithm so that it starts with the S curve. And then when it does swaps, it preserves seeds so that only 2 seeds are swapped or 3 seeds are swapped or 4 seeds. So in some sense, the S curve isn't completely blown apart, which again would be harder to justify or explain.
This is a great example of man-machine collaboration, and set the board with the algorithm, and then tweak as you need to tweak. But you're gonna do so much better as a baseline if it's set with. Look, it's not Mark Broadie deciding what the weights are. You had a long consultation about what those weights were before you ran the optimization. Adi Wyner has joined the show, and he has a question from his office on campus at University of Pennsylvania.
Yeah, great to see you, Mark. Only one question based on my partial understanding of the conversation. This seems like a job for AI. Can it do it? At least get you right towards a decent set of solutions pretty quickly?
I think AI is good at some things, but not this. No. It's like saying, let's give a traveling salesman problem to AI and expect to get a better solution than our current algorithms. No.
Well, I
it
would expect you
isn't.
to use the current algorithm. That's basically what I would expect them to do.
Oh, sure. Yeah. So
Yeah.
yeah, if you think of it that way, but if you don't give AI enough guidance
Yeah.
and it goes to try and figure this out on its own, it's not going to come up with a good
Right.
solution.
Right. Mark, you just mentioned something that some of our audience will understand and some won't. And it's worth pausing and explaining what is the traveling salesman problem?
Sure. So the traveling salesman problem is one of the most famous OR problems. And it says if you have a list of cities, think of a bunch of cities in the United States, and you want a salesman to go on a tour, visit each of those cities in some order, and you want to minimize the total travel that they take. And it turns out if you have, 20 cities, then there's 20 factorial, which is a large number
Right.
possible orderings of these traveling salesman tours. And it's very difficult to find the optimal solution. Well, 20 is pretty small now, so that can be done, but it's a problem that's in a class of very hard problems. It means as the number of cities increases, it becomes harder and harder to find the solution. But for any kind of reasonable set of cities that we have today, like the 72 college teams to assign them, that can be done relatively very fast on modern computers.
And Mark's making a general point that I think Adi set up quite intentionally, which is, whenever we have well-established models and algorithms for a solution, then they do most of the work. And AI might, unless they're fed it directly, AI wouldn't come up because that's a well-honed, decades-long optimized model. Okay, let's jump to the pros because you're also involved with the World Golf Rankings, and now we have a different set of problems because this is I was talking with Rufus about this just a few weeks ago, actually. World Golf Rankings versus like data golf rankings. It's a little bit like the college football playoff debate that happens every season between best versus most deserving. And the best is the predictive model. That's kind of the data golf model. If you're going to bet who's going to win this weekend, you want a model like that. Versus most deserving, which is what I take to be the World Golf Rankings. So I'm sure there's best in there, but you're also trying to reward accomplishment. So it's more backward. It's at least some backward looking, whereas the best, quote, best is going to be strictly forward looking. So that's the setup. And then can you talk to us about how y'all decide? Talk about weights. I mean, you got to decide what weight to put on different levels of accomplishment in order to fix these World Golf Rankings. And importantly, Mark, you weren't, this thing existed many years before you got involved. So what are the changes since you've been involved?
So, Cade, you hit on the point that I think many people, when they look at rankings, don't realize that the objective could be predictive, forward-looking, or it could be backward-looking, reward for performance. And it's easier to see the difference in the official World Golf Rankings if you just used a who's the best, what's the most predictive, then you wouldn't give any special treatment for majors beyond that they have a strong field. You wouldn't give any special reward for winning by one shot for winning, period. Because it could be, you won in a playoff and you didn't differentiate yourself from the other 2 or 3 players that were in the playoff. Whereas a predictive system, one stroke matters not very much, but in the official World Golf Rankings, winning means a lot. And winning majors means a lot more. So the board of the official World Golf Rankings and the way it has been set up for, since the 1980s when it first started, is that wins are rewarded a lot heavily. Like the ratio is 100 for first, 60 for second, 40 for third. And that decline, that exponential decline, really says one stroke at the top matters a huge amount. Missing the cut, whether you miss the cut by 1 stroke or 20 strokes, you get 0 points, which in a predictive sense clearly isn't going to be good. So the official World Golf Rankings objective is clearly not to be predictive. It's a reward for performance, sort of backward looking, but it's of course related to skill because the better players win more often. But the biggest change was trying to make it unbiased within this reward for performance system. So you want to make sure if you're giving points out this way, that a strong field gets the right total number of points compared to a weaker field. So you can still have the same exponential payoffs, but the main question then is, how many points do you give to a strong field versus a weak field event, or between a PGA Tour event and the Hero World Challenge, which is 20 players, or between that and some Asian Tour event. So that's
how do you do that?
Yeah,
how do you do that?
Let me clarify the question first. You're saying it's always going to have this steep decay, say 160-30. So 1.6.3, that ratio off the top three. But for a minor tour event, it might just be at a base of 10 points.
Yep.
Versus a PGA event might be, 50, and then a major might be 100 or whatever. What's the ratio of those things?
Yeah, we of course know, Mark, I don't know if your system relates this at all, but it's not principled really in any way. We know how they do it in tennis, for example, which is exactly that. It's 2,000 for the majors, 1,000 for the Masters 1000s, which is why they call them that. ATP 500, there's 500 points, 250. So how is it done in golf, and is it related at all to this kind of 2-for-1 ratio system?
Definitely not. And
Good.
that was the problem, that's kind of arbitrary, and that leads to biases.
Yeah.
And there were biases that you could easily see in the old system. And so the question is, what's the principled way to do it? And the idea is you take an unbiased measure of skill, in this case, a strokes gained measure, and you actually have a curve which converts that into kind of points or endowments that the players bring to an event.
Mm-hmm.
And that endowment, weaker players that have, worse strokes gained bring fewer points to an event, and stronger players bring more. And that total endowment of the players in the field is the number of points that are redistributed. And so then you get, on average, in any field, the players don't move up or down because their points that they bring to the event are just redistributed. So the players that do well or better than the points they brought move up in the rankings. The players that do worse move down. And it's an ELO
system.
It's a standard of any ranking system ought to be that way, that if your expected performance, if your performance matches your expected performance, you don't change the rankings.
Right.
And if you outperform your expectation due to the rankings, then you should move up or move down.
So it's Bradley Terry is optimized using the EM algorithm, and you just, if you're at your expectation, you don't change.
Well, so
Correct.
it's lovely because you said principled, and I was kind of like, well, I want to see this because it wasn't clear to me how you're going to come up with a principle for these ratios. How off was it before, Mark? Without throwing anybody under the bus or too much shade, like how big an adjustment was it?
Not just that, good Cade. How the hell did Mark get them to actually adopt that system? I want to hear that part of it too.
Yeah, right.
Well, there's two parts of that question. So one is, and I mean, we kind of showed with Dick Rendelman, a colleague of mine, that there is great bias, but it's easier anecdotally to see that you could have a particular player, in this case, say from the Japanese tour, and they used to have these World Golf Champion events where they'd bring the top ranked players, top 72 or 75, and invariably players from some of these lesser tours that happen to just make it into the top 75 would be destroyed in the tournament by many strokes. Mm-hmm. And you could see that they always, when you got them together in head-to-head competition with the other players, you could see that their ranks were misaligned, were out of whack. So to answer Eric's question, how did this happen? Well, Dick Rendelman and I wrote this paper, and like academics, we thought this would affect some change, but no. Unlike, we showed drive for show, putt for dough is not right. Here, when we showed the official World Golf Rankings in the past iteration were biased, people said, yeah, we knew that. It was really? But then how do you get it to be fixed? Yeah. And basically they got the official World Golf Rankings board decided that they needed a mission statement, and the mission statement was to fairly rank golfers, not to just reward certain tours for one reason or the other. And they did an analysis independent of what Dick Rendelman and I had done. 5 other groups did independent analyses that came to the same conclusion, that the rankings as currently they stood at the time were biased. And so now they had a mission statement. They want unbiased rankings, and they have independent academic expertise saying they're biased. So what's the fix? And that's what led to the change.
Mm-hmm. It's interesting. So then so let me just check. I just want to think about this. So if I'm a good player, I want Scheffler or potentially Scheffler or McIlroy. Well, when they're not in the field, there's less than total points brought to that event, which means there's less, I'll call it, bonus for winning. So beating them, I mean, it's what you'd want. You'd want that to be true, but of course your probability of winning goes down. So have you ever thought of the problem of, like, let's say I'm the number 10 player in the world, okay? I don't even know who that is, but I could make up a name, but let's say, I don't know, whoever. Let's say I'm the number 10 player in the world.
The number 10 player in the world golf rankings is Xander Schauffele.
Okay, that's a great name. So I'm Xander Schauffele. Should I want McIlroy and Scheffler not to show up? Now, the bad news is those points aren't coming their way, but of course my probability of being higher up the exponential curve goes up. So have you thought about the problem of optimal field depending on where I am in the rankings?
Absolutely. So
good.
This was designed so that question that you just asked, you're indifferent between whether Scotty and Rory show up or not if you're Xander Schauffele.
Right.
But
beautiful.
If you take it to an extreme and you say, we're going to give Eric Bradlow a sponsor's exemption into a no-cut signature event. Okay?
Yep.
You would not be in the top 10,000 of the official world golf ranking, yet because it's a no-cut event, you might get a few points, and that would be unfair. So it works for almost all events, but not if you take a large range from, the Scotty Schefflers of the world to the 10,000th ranked player in the world. So Your point is, academically, it's perfectly correct. In practice, you don't have that large a dispersion in the quality of the field.
I'm sorry, but just to be clarified, does that mean that in expected value it's sort of balanced? It's indifferent?
Yes.
Okay, but not necessarily. But you could have other loss functions that could be optimized differently.
On average, when professionals play in events, they neither go up nor down in the rankings, unless, like I said, you're Eric Bradlow on a sponsor's exemption. Then on average, you're going to go up.
All right, Mark. I'm curious, especially now that this has been jiggered a little bit, when it comes to like Ryder Cup selection.
Yep.
How do the world golf rankings play into that versus predictive models like Data Golf's? And some of it, are the captains restricted, or some guys automatically qualify, but that's a world golf rankings automatic qualification. But they've scrunched that down a little bit to give the captains more discretion. Do you have any sense of whether captains just want the predictive, or do they put a little value in the most deserving because they might think that it captures an ability to win under pressure kind of thing?
So they've changed from like 10 out of 12 were automatic qualifiers, now like 6 out of 12. Mm-hmm. So the captains tend to have 6 discretionary picks. And I would say most of them are based on predictive and looking forward. And then the question is, well, something like strokes gained or the data golf rankings, whatever, don't take into account necessarily course fit, recent play. And the question is, how do you weight those factors?
Right.
And so you're still trying to make it predictive, but you're including additional features that aren't necessarily in the raw numbers.
Okay. Mark, we are coming up on the time we'll need to let you go, but I do want to ask one kind of general question about you and your experience with golf analytics. When you created this concept of strokes gained, you probably could have only fantasized that it would be as impactful as it has been. But I'm curious, years on now, what is one place it's gone or something that's come from it that has surprised you or that you never would have anticipated? Because it strikes me that it's this tool, it's a method really, and any good method is going to find new and unexpected uses. So I'm just curious your experience with it. Where has it gone that you might not have anticipated?
Well, I did not anticipate that most professional players and coaches and college players would be looking at this, but
Mm-hmm.
for the most part, they are. I
Mm-hmm.
didn't really anticipate that it would form the underpinnings of an official world golf ranking.
Mm-hmm.
And I didn't really anticipate that many bettors like Rufus would also be using this as, step one in their betting system. So
Mm-hmm.
it has had a lot more uses than I ever imagined. And also surprising, when I started teaching the sports analytics course at the Columbia Business School, is the strokes gain concept is now in most modern stats that are coming out. So rushing yards over expected and
Mm-hmm.
many other kind of new stats in football and many other sports have this idea of performance over expectation. And that's basically what strokes gained is for golf.
Mm-hmm.
I mean, it's XG in golf, in soccer.
Expected goals in soccer, expected goals in hockey.
Hockey, guys, it's April or it's May. It's hockey. Come on now, Eric.
I just have to ask Mark one question. When I think, and this is one academic to another, when I think of some of the things that I'm most quote unquote famous for in academia, it's none of the things that are particularly the most technical of my work. So can you just give us a sense briefly, like, I assume strokes gained is not the most technical thing you've ever written. And so does it bother you? It doesn't bother me at all, I'll just tell you. But does it bother you at all that the thing you may become most, or you are most famous, I don't know, or the most cited for is something that isn't as technical as like your training?
No, it doesn't bother me, because as academics, I think we try and come up with ideas that have an impact. And this is an idea that's had way wider an impact, but not on academics, but on, the real world, at least as far as the golf world or the sports world is concerned. So I'm not embarrassed at all. And I, in many of my talks, it said, who would have guessed that you could get so much mileage out of a concept which is subtracting two numbers?
Right. Well, there you go. That's a good counsel. That's good counsel to us and some of our listeners, that it doesn't have to be the absolutely most technically proficient thing to make a contribution. Why don't we leave it there? Mark, greatly appreciate your being with us. Always enjoy the chance to visit with you.
Thanks so much, Cade and Eric and Adi. It's always a pleasure. Thank you.
Mark Broadie, Carson Family Professor of Business at the Columbia Business School, the creator, literally the creator of Strokes Gained, and a longtime friend of Wharton Moneyball. Come back and join us after the break. We have another half hour still ahead. Welcome back. Welcome back to Wharton Moneyball. Welcome to the second half of this week's show, Tuesday afternoon, as it usually is when we're recording. The show will go up bright and early Wednesday. I think Dion gets this thing going early Wednesday. Eric Bradlow is in here with me. This is Cade. Adi Wyner is in here now, rolled in to his office about halfway through the first segment. Shane Jensen out and about doing Shane Jensen things. He'll be back. I think he's on a bloody committee right now, the poor guy. He'll be back just off the line with Mark Broadie. Always enjoy talking Mark. I didn't know he'd done all those golf rankings things. That was good fun. And that's a neat little extension of his stroke.
And tournament design as a result of it.
Yeah, it affects tournament design. That's great. We have a handful of topics to hit, some big, some small. But Odd mentioned last week on the show that he had done a little work on the ABS, original primary research that Adi is prone to do on occasion, just kind of spins it off. Some of us eat lunch kind of naturally. Some of us drink coffee. Some of us go for walks. And Adi just spins off original primary research on things like the challenges in baseball. So what do you got, Odd?
Yeah, so it's all new. So we're really interested in trying to figure things out. And lots of analysis are being done. In fact, the MLB has its own website devoted to challenges created by, as usual, Tom Tango, who is not a real name. That's a real person. That's not a real name. And he's looking at essentially challenge rates and success rates, but he kind of creates his own denominator of challengeable pitches, and he's kind of have his own thing. So what I asked the question is, think about a universe where every wrong play was turned to the right one.
Yeah.
Okay. Good. All right. Mm-hmm. And now accumulate all the, what I call run expectancy flip caused by flipping the wrong play to the right play.
We're just talking about called balls and strikes now.
Just called, exactly. Just
and only when they're challenged.
Well, no.
All of them.
All of them, right? And so every team will have a defensive set of run expectancy they could reclaim by challenging, and offensive run expectancy that they can reclaim by challenging. So I wanted to ask the question, how much of that pile, if you will, that's available to them, are they reclaiming?
Okay, first, great, cool, but give us some context. How big is that pile, and how's it distributed?
Well, it's actually pretty big. It balances out, so your opponent is missing or is being denied about the same amount that you are. So it's not like it's a bias. But if you can recover more than your opponent, that's actually an advantage, substantial. Per game, it's getting close to about a quarter to a half a run.
All right. So Adi, just remind me, per team?
Yeah, per team. It balances out. So it's equal. So it's not like one side is advantage.
That's like 5% of the number of runs that are scored. So that's a lot.
Yeah, it's a little less than that, but yes, it's a lot. Yeah.
Okay, and just correct me if I'm wrong. How many, before I answer your question on percent, can you just remind me of how many challenges I get, and if I get it right, because that matters. Because if I could infinitely challenge, then that's a different thing. But obviously I cannot.
Okay, so obviously you'll get all of it if you can infinitely challenge.
Right.
But you just keep challenging until they make it right, and at that point you give up the system and you just let the robots determine all the value. But that's not the system. The current system allows you to. And every time you make a mistake, your amount is decremented. So you can do as many as you can until you hit 2 errors. So it's a classic. So that's a wonderful system.
It is a good system
because it actually is a lot of fun to sort of think about from a operational strategic perspective. What should the teams do? And the players are kind of working them out. Now we've learned a few things. We've learned that catchers are much better than hitters and pitchers. Catchers are best at this. They're the best view. They also don't have the emotion. Jazz Chisholm is the worst. He has challenge pitches right down the middle, and he's already an internet meme for looking at the camera, going, "Oh, what am I doing?" Most players
also catchers have caught a million pitches, and so they're calibrated for this.
Exactly, but they make errors as well. The catcher error rate is around 60%, and the position player, getting backward. Success rate is around 60%, and the position players are in the mid 40s.
Well, that already gives us some information. So, look, the 2 factors that help me determine reclaim percentage is the hit rate, or how successful am I when I challenge.
Yep.
But also the distribution of when I ask for it, because I want to ask for it. For example, if it's bases loaded and it's 3-2 count and a marginal pitch comes in, I should challenge that pitch because that's potentially worth a lot in terms of expected number of runs.
Absolutely.
And
so people have recognized that your decision to challenge depends on 2 factors: your probability that you're right, which is how bad the call was, and of course the run expectancy that would flip.
Didn't I just say that?
Exactly right. And people have recognized that.
Right.
But people have not. There's no algorithm that anyone has made, and as yet. And our team is working to create that, but we don't know the algorithm right now because there's a problem. You only get a resource of 2. So you have to husband that resource and think about it properly. So the question that I went out to answer and did answer is a very simple one, which is what percentage of the run expectancy that is out there for you to reclaim are you actually getting?
Okay.
And among the amount that you're missing, are you missing it because you're running out of challenges and therefore you can't challenge? That's really horrifying, by the way. If you're watching baseball and it's the 8th inning and there's a strikeout that is a bad call and you're out of challenges, that you're pulling your hair out. How much of the missing challenge missing RE is caused by lacking the ability to challenge because you're all out?
Yes,
and how much is it missed because you're just not challenging?
Can I ask you a clarifying question?
Sure.
Why you decided to study runs as opposed to win probability?
Eric Bradlow with the home run question. The answer is it's a lot more stable, and it doesn't depend on context, and it is it'll be the same no matter what inning you're in, and it is and there's a lot more data on it that's reliable. So win probabilities can barely move with a strike in the first inning. But a run expectancy is a measurable and determined quantity. So it really is a statistics argument.
Yeah, the only reason I'm asking because I think it's a good question. I'm glad you thought of it, obviously. But also, the reason why you might see a percentage lower than one might expect is because you've created a metric, but the team, I'm being generous. The team may be trying to reclaim win probability, not runs, and therefore that's why you see a lower percentage in your metric than you might expect.
So I actually think,
real quickly, you can imagine psychologically regret is more closely associated to win probability than
correct
runs. Even though I 100% agree with what Adi's saying and doing. And by the way, that's something Adi has said over the years about like expected points versus win probability in different sports. So I kind of knew where he was coming from. But you can imagine regret, like even the hair pulling out in the 8th inning, that's a little bit closer.
All right, do you want my answer, Adi, on the percent?
Well, let me just to respond on that as well. Like in 4th down decision making, the right thing to do is win probability. In decision making in football, everything should be win probability. But a lot of decisions are made on expected points. And one of the reasons for that is there's just many more independent possessions. Possessions are evaluated on the point basis. Win probabilities are all related, right? So you have much more data to accurately estimate things when you're dealing with possessions and the points rather than win probability. And so we know much more about run expectancy than we know about win probability. And so we have to recognize the limits of our data. So also one of the things that I also tell my students, start with the easy thing, for God's sake.
Yeah, exactly. Good. Okay.
All right. So you want to make some guesses? What percentage of the available RE is being reclaimed?
I got it. I understand the question.
And give me a defense and an offensive number.
Well, clearly we know that defensive is going to get more because catchers are better.
Yeah.
I don't have a calculated answer, but my intuition is like just a very small fraction. I don't know, 10%, 15%.
I was going to guess a third.
Okay, so you're both in the ballpark. It is small, and no one is at a third. But defense is around 27%, and offense is around 19%. And that's only through April 29th when I ran the data.
See, Eric, we should have asked if we could pool our guesses, and we would have hit it.
You would have nailed it.
Yeah, exactly. Model average.
That would have been the right thing to do, as you guys all know.
Ensemble. We just have to demonstrate it.
Now the real question is, the second question, which I know the answer to, is how much of the missed challenge, which is roughly between 75% to 80%, how much of that missed challenges are caused by not having challenges?
Yeah, right. Small number, a quarter to a third.
I'm going to guess more than that. I'm not going to guess. No, I was going to say half.
Now we're going to average.
Which side? Which side? That doesn't matter. Eric's half is this. So how much is lost of the remaining chunk that we're missing? Take out the ones you're getting.
Yeah, if I had more challenges, I could regain half of that. That's my comment.
So I'm not asking the question. That's a totally different question. If I had 3 challenges, how much can I regain? I'm asking you just an observational question of the challenge run expectancy that you have not reclaimed. How much of it is missed during the periods of time where you have no challenges?
Yeah.
Then it's small. Then I'm going to go back to what Cade's saying. I'm going to go with a quarter.
It's actually much smaller than that. Much smaller. They are barely missing any challenge because they don't have it. It's about 5%.
So they happen to pick the right number of attempts too?
No, I just think they're underusing their challenges. That's my guess. They are underusing their challenges.
That's another explanation.
Okay.
I got plenty of challenges because I'm not using them.
They're just not using them. And where they use them, but they don't use them enough. I think the teams, once they blow one, are just I just think they underuse them. And particularly later in the game, I think they're underusing them. 7th inning, 8th inning, and the 9th. I mean, come on. Just use the goddamn challenge.
Is this the same as like sitting your guy with 2 fouls in the first half?
Yes.
It's like you're trying to preserve something,
yes,
and you're being too conservative about the preservation.
Yep.
Or it's like you're starting actually to see Adi's point actually in the NBA now. Like you're starting to see at the end of games, like it was a foul. But what the hell? Let's challenge this thing and see what happens. There's 15 seconds on the clock. And you know what? We're going to lose the game if this thing isn't overturned. There's no cost for me to see. Maybe some gets in the ref's eye and he says, no, that's not a foul. Who knows? Well, I'm starting to see it in the playoffs. I've seen ridiculously bad challenges in high leverage situations.
Are there no penalties for overtime?
You get a certain number, but it's
lose
at
the
the end of
challenge.
the game.
That's
It's at the end of the game. You're going to lose the game if this isn't reversed. Give it a shot.
Okay.
So that's the real question. So the answer, the unknown now is what's the right policy?
Right.
Yeah, right.
Don't know it.
Are you observing different teams following different policies? Is there much heterogeneity? Is there already learning?
Adi could have been talking about two different things, Adi. Do you mean MLB's policy, or do you mean what Cade was talking about, which is the team policy?
The team policy. I'm not changing MLB.
Oh, okay.
By the way, so I'm able to rank teams by their ability to recover challenges. And actually, Philadelphia is very good on the offensive side. They've been recovering a lot of challenge. They may be doing that because they're actually challenging a lot. And in fact, this gets to the psychology. When you challenge and are wrong, they often feel the heat for that. And I think in a way that's probably not deserved. A good challenging team should be not ending the game with challenges. You screwed up if you did that, which means that you have to bear the brunt of what might be considered silly challenge.
Adi, can you tell us the probability? If I have on the y-axis the probability of successful challenge, and on the x-axis the distance from the strike zone, what does that curve look like?
I actually have so I don't have that number because it's very correlated with that. But I'll start with the first number, which is I can tell you the probability of an umpire error as a function of the distance from the strike zone.
Okay.
I fit that curve, and by the time you get to 3 inches, the probability is nearly zero.
Yeah.
And it interpolates fairly linearly.
What is the diameter of a baseball?
Just under 3 inches.
All right. So it's basically once it gets to more than a baseball outside of the zone,
they tend to be very, very good.
That's good. I'm glad. Thank you.
The umpires, by the way, the umpires are awesome.
Yeah.
I mean, we laugh at them and think, 92.5 is their success rate. Do you have any idea how many pitches are right on the border? These are professional pitchers we're talking about. They throw it on the corners and on the edges. And when you're on the edges, their probabilities are roughly 50%. I mean, it's very hard to get right.
The trouble is, and this is one of the reasons the challenge system is so great, is that there are outliers. I mean, they are human beings. And the outliers, if you can zap those, then you've made a lot of progress. Why don't we let that sit there for now? This sounds like an ongoing project. Adi will be able to come back to us on some things. I have I'll do some other baseball trivia for y'all. Trivia is the wrong word. I'll put you through your paces a little bit. Did y'all happen to see this Wall Street Journal article about the Brewers the other day? They looked at how overperforming they are over the years. So Fangraphs preseason predictions for number of wins over an 11-year period of time, 2015 through 2025. So 11 seasons. The Brewers have been the most outperforming of the Fangraphs expectations. And you can go to like Pacoda, you can go to somebody else's system. They're also the top there. What do you think the average number of wins above expectation the Brewers have achieved over the last 11 years?
Wait, let's so what is the wins?
How far in wins above
observed Brewer wins minus Fangraphs expected wins, sum it over 11 years and
divide by 11?
Yeah. And I've guessed 5.
I would guess 3.
7.5.
What?
Right? And that's 11 years stat. Dodgers are 5.1. Astros are 4.8. Your Yankees, who seem like underachievers to me, are actually 4, but the Brewers are 7.6. And
does that say more about their model than anything else?
Well, I think the article, is it Jared Diamond? He's always doing these kinds of articles. I'm not sure if it's him. Let me look real quick. Jared Diamond, as a matter of fact. This is May 4, so yesterday. They say it's development. This is a small market team, small budget team, and they say they are making players better, more than they're expected to, and more than other teams are. And if that's true,
they're also relying heavily on youngsters, because if they're not youngsters, they would be priced into the preseason expectation. So if I'm getting this right,
unless they're just turning them into, they take a veteran and they make them better than they were before in some way. I mean, this was the story for the Astros all those years. Like Astros were first into development. Now we talk about baseball being this way, but apparently, seemingly, at least by this article, they're ahead of the league on that.
But Adi's got a good point in that, like, when residuals like this tend to be persistent, any good statistician would go back to the model and say,
Yeah.
I'm missing something here,
Yeah.
you know.
But what if it's a team effect, and then you're just going to put your thumb on the scale
All right,
and have a Brewers fixed effect? That's not the way you want
That's
to model.
7.5. That's a big number,
right? And
Yeah, it all depends. Listen, they don't tell us what their forecasting system is. I don't know what that is. That is a very big number. And it is time for us to just shout out a former student of ours, Eric Babbitts, who is the director of player acquisition for the Brewers and has been there since he graduated 5-6 years ago.
At the Brewers?
At the Brewers. And,
how about that? Well, heck, let's get him on the show and find out whether Jared Diamond's article is actually capturing what's going on. I mean, he's right in the middle of that stuff because he's charged with finding people that aren't going to break the bank because they're a small budget team, and yet they believe they can make better. That's his charge.
That's his charge.
That's interesting. Okay, let me give you one other baseball question. I don't know how I wasn't calibrated for this, but so the women's softball season is winding down. Their postseason is great fun. Top shortstop in the country, Isa Torres, Florida State. She's got a big bat. She makes offensive contributions, but she's also great defensively. What do you think? Let's say, I don't know if this is true, but let's say she has the top fielding percentage in the country. What do you think a shortstop, women's college softball shortstop? What do you think the top fielding percentage would be? And I'll give you the number. Well, you might even guess what's the number of chances. There's a simple thing to guess.
How many games are there in a season? 30 or so?
About 30. Yeah.
And I would guess chances are probably in the. There's so many strikeouts, probably between 6 or 7 chances a game. So I'd go for about 150.
You're dead on. 142. I thought it'd be higher. 142. So Isa Torres, 142 chances this season, led the country in fielding percentage. What do you think it was?
So I bet she got about 138 of those 143. Maybe my guess.
So that's 97, 98%.
Yeah.
That's what I was going to guess, somewhere between 95 to 98%.
What's your upper limit?
Well,
100.
Well, I know that's your true max, but would you?
Yeah.
So she's 100%. She had no errors this year.
She had no errors. That's amazing.
Playing shortstop.
Now, let me ask you a question about that. Okay. So let's suppose you have a known statistic. So let's imagine there's a play that happens now or whenever during the season, and the scoring person says, "You know what? Let's tilt this to the no side."
First baseman should have scooped that ball.
Exactly.
That was not a bad throw. Okay, that is wonderfully cynical, Eric. Well done.
That's
okay. Let's do one last one, and this is more involved. And this is the paper y'all saw that Dylan Wewad. Dylan Wewad is with SLAC. He's a quantitative researcher with SLAC. He is a social psychologist out of Simon Fraser, making him Canadian. And he did the Northwestern Kellogg's Graduate School of Business at Northwestern, as Eric knows anyway, has had postdocs for years, great postdoc program. He did that, and then he's moved on to SLAC. But he's rediscovering his love of hockey and is running some quantitative analysis. And so I want to ask y'all. So he sent us this paper, and he's a published academic. And so when he writes a paper, he's going to write it, soundly like an academic. So it's this impressive, only 15 pages, but very strong methodologically. I want to ask y'all, because he takes on an interesting challenge. He goes to measure depth in hockey. And one of the reasons he sent it to us was that we talked to Eric Tulsky a few weeks ago, the general manager of the Carolina Hurricanes. And Tulsky's whole thing is basically depth. They've built their whole roster to be deep, like less top heavy and just deep. All 4 front lines, all 3 back lines, whatever. They're gonna have guys that can play.
Is there an agreed upon measure? Like you can imagine like entropy of skill set. You can imagine max minus min. You can imagine taking lines and looking at the summation of some metric and looking at lowering the variance. Is there I'm saying, is there no, okay. But you mean something like this. But you mean something like this when you say depth.
If we take Dylan to have done a thorough lit review, and I don't know that was his objective, so we don't know, but he's acting as if he's creating this. I suspect some teams have this. Some teams, certainly Tulsky has done this, but as far as we know, there's no accepted measure. So I'm asking y'all how you go about doing it. That's just a neat little paper by Dylan.
I just came up with 3 measures right there. So you have some strength parameter for a player. And so depth would be, it depends on meaning across the whole team, or you could mean across lines. You could, matter of fact,
team.
Around the team. Well, there's classic measures of, variance is one. you could have some sort of
just look at the difference. What's the rate of scoring per minute among each line, and look at how that erodes look for big drop in 3 and 4 in some way.
So you want to use scoring, Adi, as opposed to like some sort of strength measure?
Well, you can make a composite measure because there's obviously offense and defense, but I think the lines are different. I mean, they're misaligned, right? You're out of my pen here, folks.
No,
right?
But let's.
But isn't there offensive players and defensive players?
But you're asking a good question. Suppose
let's straight offense. We're going to play.
So I want to look at your rate of scoring, and then compare that across the lines either per possession or per minute, probably per minute.
Okay.
And then there's also a power play issue because I think you bring in your top line.
You could do that. Yes, you could do power plays. Sure. Okay. So let me just walk you through a few of the steps that he does because I think it's thoughtful and interesting. Let me say it's relevant also because he ran the numbers on this year's NHL, and Carolina is like a standard deviation beyond everybody else on this measure. And in his analysis, it shows that it's predictive. It makes contribution above baselines on the likelihood of a team winning.
Okay, so it's after controlling for a bunch of other things like that you'd expect. There's incremental contribution.
That's right.
Can I just shout out to? Go ahead, finish.
Well, I'm going to give you I'm going to give you a couple of steps on methodology because I thought they were nice. First, it's at the player level as opposed to the line level. So he'll take a stat. He'll take a stat like ice time, or closer to what you might care about, like XG, expected goals. He looked at also things like assists and shots on goal, and he ends up with a suite of these statistics. And in each case, he asked, what's the complement of the Gini coefficient? So y'all know the Gini coefficient is this IO kind of it's a concentration measure.
Yeah.
And so he's asking how concentrated is the ice time or shots on goal or expected goals among the players, the offensive player or the skaters. It's all obviously defensive players can have XG as well. So that's the basic measure. But then he models the whole thing as a latent variable. And so I think this is something that we ought to listen to. I think there's a nice contribution because he's saying, look, it's not one thing. XG, like the complement of the Gini coefficient of XG for a team is an imperfect measure of depth. But if we get 3 or 4 of these things and ask, is there a latent variable?
Yeah, you mean basic. I'd say this is basic measurement science. You don't measure a construct with one thing. You use a bunch of manifest variables that represent some underlying basic concept, which is why I was thinking of some sort of strength model. You could call that latent thing a strength thing, which is manifested itself in different different observables.
Yeah.
Well, I'm excited to look at his paper, Cade. Thanks for bringing it to our attention. I will just point out that was the qualitative question that we asked our high school students in our competition.
Is that right?
They were asked to essentially evaluate whether depth, we didn't call it that, we call it line variance, how that affected winning. And that was the final question for their high school students. And
maybe you should just say a few words what you're I obviously know what you're talking about. You should just say a few words. What is the Wharton High School Data Science Competition?
Happy to do that. So Wharton Analytics and AI at Wharton, we sponsored a major competition for high school students, and we created a fake hockey league. They played each other all season, and then we asked the students to forecast the outcomes of the playoffs. And that was all very forecasty and very rigorous and quantitative. But then we had them ask an open-ended question, like a hockey question, which is, what is the relationship between having a depth, which is the right word for it, and winning? And we asked them to study that. Wow. And it was actually very hard because there was a very strong confounder, which is the top lines also play against the top defenses. Yeah, and so you have to control for the quality of the defense that they play against to measure the quality of your top line. And if you didn't do that, you thought that your lower lines were better than they were because they were playing against weaker defenses. And I will tell you that one team managed to do that out of the 700 submissions.
Well, I know who it was because they presented actually at the Wharton AI and Analytics board meeting. I assume you mean the Pingree team. Is that the team that won?
They were the team that won. I'm not sure they're the team that figured that out because it was so esoteric that there were so many components to the program.
All right, guys. So we'll let that one go. If anyone's interested in chasing it down, Dylan's website is hockeydecoded.com. hockeydecoded.com. Thanks, Dylan, for sending that to us. And listen, guys, we're always interested in the work. And, to be fair, the more put together the work is when you send it to us, the better. But we'll take work in progress. We'll take data. We'll take websites. And Dylan, maybe he got lucky. He got me in a moment where I could pause and read the paper. But we love that you guys send us stuff on occasion and we learn from it. So please keep it up. Fellas, what else around the world of sports right now before we have to run?
Well, just one thing for me, I always love talking about tennis, but, Jannik Sinner's done something no one's ever done. He's won 5 straight Masters 1000 titles. And no, not Federer, not Djokovic, not Nadal has ever done that. And my prediction is, I don't think, unless he gets injured, I don't think he's going to lose until Alcaraz comes back. I mean, the gap between him and everybody else. Look, he just played Zverev, who's number 3 in the world. He beat him 6-1, 6-2. It's the 4th straight match he hasn't given up more than 6 games to Zverev. And that's the number 3 player in the world, okay? And Djokovic is injured right now. Maybe Djokovic beats him on a bad day for Sinner. But the gap is so large that he may win every tournament he competes in, assuming he stays healthy right now. I don't see any reason why he wouldn't be. I have to start looking at the betting odds, but you have to put him at minus 400 minimum for any tournament he plays right now.
That takes the fun out of it, doesn't it? That's a little too heavy. How long is Alcaraz out, you said?
It's hard to know. I mean, he's not playing the French, which is upcoming. They're not at the French yet. They still have, I forget which one's next, the Italian Masters or whatever. But there's one more tournament and then the French, and Alcaraz is already saying because of his wrist, he's not playing the French. Mm-hmm. So,
wow.
Yeah. So that's what caught my eye.
All right. We should note that 2 Philadelphia franchises are in the second round of the playoffs. That's not nothing. How long's it been? How long's it been since that happened? Both Flyers and the Sixers are into the second round. That's pretty good. They're both getting whipped right now in that second round, but presumably the Sixers will bounce back. I assume that Knicks first game was just because of how rough that.
Well, the Knicks, by the way, have set. I mean, whatever this is worth, it's a small sample. The Knicks have now set a playoff record. They've won 3 straight, but they're combined. They've won 4 straight, I think, playoff games now by 25 points or more, which has never been done before. So the Knicks are on a heater. They were down 2-1. Just remind everyone, they were down 2-1 to the Hawks. They beat them 3 straight by plus 25. They beat the Sixers by 39 last night. So whatever heater they're on a wrecking crew mission right now. And you're right, the Sixers may bounce back and lose by 15.
Okay. Now the one concern potentially is that they were winning and then the team starts to try to get desperate and then it ends up creating a gigantic margin. If it doesn't work,
they were beat pretty early on this game.
Yeah, I have to say, I was in Penn
pretty quick.
I was in Penn Station when the Knicks were playing their last game of their first series, and at the bar in Penn Station they had the game going on, and I turned over and looked, and I saw the score, and I'm like, that can't be real.
Right, it was like 90-30 or something. No, it was an unbelievably unreal score.
But it's there's this thing in tennis that I think is known. That tennis players, if they get behind in a set, sometimes just say, I'm going to lose the set. I'm going to conserve energy. And I think this happens in basketball series as well, that sometimes a team will get sufficiently behind. They're like, we're going to conserve energy this time. We're going to come back.
Well, Cade, I mean, let's remember the Sixers played 7 games. Yeah. They ended on Saturday. So they had to fly down from Boston. By the time there was blown out, I know for a fact Embiid, Paul George, Tyrese Maxey, they were all pulled in the early to mid part of the third quarter. Because they're playing again tomorrow. I'm saying there's no rest. There's 1 day rest. Obviously, the game's over. Tank this game and go for the next one.
Yeah. I'm worried about that in the Eastern NHL playoffs. The Canes are up on the Flyers 2-0. They're big favorites anyway. They might sweep them. The team I'm pulling for, the Sabres, haven't yet started their series against the Habs, and so it could be that the Canes get out and have like a 10-day break before
get rusty.
Then you hope for rust. That's exactly right.
All right.
Let me give you one other thing, guys, before we go. The NHL draft lottery is today, so there's a few wrinkles here that are just a little bit interesting. But by the way, the presumed number 1 pick, it's not 100% sure, but the presumed number 1 pick is that kid that's at Penn State. He kind of unexpectedly went to Penn State when Penn State was practically just an intramural team still, Gavin McKenna. And by the way, he's like 6'170". It's just amazing to me that a guy on the hockey ice 6'170", which is a very average sized guy, could be that good. But setting that aside, the top odds for the worst performing team last year, the Vancouver Canucks, is 25.5%, 25% chance. It's pretty good. And then it drops to Blackhawks are at 13, Rangers are at 11. And here's something for us to pull for tonight. In absentia, Shane Jensen's Calgary Flames are the fourth highest probability of getting the number one pick, 9.5%. So
wow,
we should all be pulling for the Flames.
They haven't done quite as much flattening as
that's right.
like the NBA has done with the draft lottery, etc. Or where they haven't even, there's tiers. Like the bottom four in the NBA are all at the same percentage now. So in other words, you can tank, but there's no reason to tank from third to second.
They haven't. I don't think they've done that yet, but they're talking about making that last change you just said. But there's another wrinkle in here that I've never seen before. We talk about tournament design, but here's lottery design. Of course, we're hearing a lot about it from the NBA, but I think this is just going to exacerbate what you just said. They have separate draws for the number one and the number two pick. I think that means in the NBA, they'll count down like 10, 9, 8, 7 to 1. And so it's one draw all the way through. I think that means they're going to choose a ball for number one. And they're not just going to do a full. Well, would it make any difference? And that team will obviously be removed for the next draw. Why
that team's probability should be that probability. Let's say it's 25.5. You said that probability should be distributed equally. In other words, it doesn't violate what we call the IIA property, meaning the remaining 74.5% probability still has the same ratio amongst all the other teams. So there should be no impact.
Yeah. So why would it matter? Maybe I have it. Maybe I
shouldn't. I don't know what they're doing and what they're doing wrong.
That must not be what they're doing.
Anyway, I just want something for a future show, but I have a group of students from my Moneyball Academy over the summer. They studied the rate at which value is lost as you go down the draft curve for all sports. And hockey, surprisingly, gets the incredible amount of value from the top of the draft, and it drops quickly, but way more than other sports. I was surprised. I didn't realize how predictable a top-ranked hockey player is in terms of value.
That sounds like the difference in predictability is what you're talking about, though.
But even it starts high, it goes and then it stays high and it goes down. But it's amazing. So the metric they used was all-star appearances. And they are a lot at the top of the draft.
Interesting. And did you have any sense of where the other sports come in?
Yes, we have that. We'll have to talk about that at a later date because it's a great little study.
Well, it's surprising given the long development time on a hockey on most hockey players. It's much more like it's in the direction of baseball as opposed to like a football or basketball. Okay, guys, that's a pretty solid show. Well over an hour here. It feels like we haven't talked in a while, and we did some today. We'll let it go there. For the whole team here, Eric Bradlow and Adi Wyner joining me, Shane Jensen in absentia, Dion Simpkins, the big boss behind the scenes, making this thing happen for more than 12 years now, Marissa Reyna, our producer, and Dee Patel, boss lady, keeping us all in line. Thanks to that whole team. Thank you guys for listening. Come back and join us next time. Between now and then, enjoy your sports.